Hello everyone, welcome to my YouTube channel. My name is Pauline Basani and I'm going to be taking you through the fundamentals of machine learning. That is basically explaining what machine learning is, how it works, how we use the different models and algorithms to come up with solutions to real world problems. So machine learning is basically understanding how computers learn from data that is given to them. Traditionally, if you had given a computer a task to perform, you need to give it the instructions on how it's going to perform those tasks that have been given to it. But machine learning enables us to come up with ideas on how to feed the computers with data and expect results from the computer just from the data that has been given to it. So machine learning has two approaches, that is supervised learning and unsupervised learning. For supervised learning, the data that is given to the models is labeled data. This means that the outcomes are known. So the models learn from the data by comparing their predictions with the outcomes that are already known. While for unsupervised learning, the data that we work with is unlabeled. So the models learn by discovering the patterns from the data that has been given to them. And unsupervised learning is best used in cases where we are making insights rather than predictions, because all the model has to do is to discover a pattern, therefore it can make the future insights. So next I'm going to talk about data preparation, which is the foundation of machine learning. During data preparation, first of all, data preparation happens before the model is built. So we are basically working with only the data. And here we have data collection and data cleaning. During data collection, we gather the data that is going to be used from multiple sources. And the goal is to make sure that the model is given enough data in order to perform the tasks that we want it to perform. So if we are getting data from a source that's not verified, that means we are going to feed the model with data that may be incorrect. Therefore, the results that you're going to have from the task may also be affected by the data that has been given to the model. Then we also have data cleaning. Data cleaning involves removing duplicate entries, identifying and addressing outliers, and handling missing values. These missing values can be handled by imputation or deletion, though it's important to take note that deletion is not advisable because it could cause loss of necessary data that could be used by the model. So it's better to impute than delete, but we can also delete where it is necessary if we are sure that the data we are deleting is not going to affect the performance of the model. Then next, I'm going to talk about exploratory data analysis, which can also be called EDA. This is a crucial data inspection phase where we analyze the data that has been collected. And it is at this point where we do data cleaning to ensure that there are no missing values and things like that. There are no errors with the data. Then we examine, summarize, and visualize the data in order to identify patterns and build models that are going to perform the tasks that we expect them to perform. So we use histograms, box plots, correlation analysis, and so many other things. And at the end of the day, we carry out EDA in order to identify distribution patterns, feature relationships, identify issues with the data that has been collected, and this is where those issues are rectified before the data is fed into the model. Then I'm going to talk about the different models that we have in machine learning. First of all, a model is a representation of something phenomenon. We have two categories, that is deterministic models and probabilistic models. For deterministic models, they have no randomness. That means the models assume exact predictable relationships. For example, if a model is told to identify what gender this person belongs to, it is either they are a girl or a boy. There is no in between. So the answers or the solutions that these models provide are discrete. So we have exact solutions to the problems that we are solving using these models. Then for probabilistic models, there is randomness. These models provide probability distributions as output. There's no exact solution to a problem, but we could have a range of solutions to the problem from which we get the actual solution to the problem that we are solving. So the solution to the problem depends on the problem context or the kind of problem we are dealing with. So there are three types of probabilistic models, that is regression models, correlation models, and other models. Next, I'm going to talk about the KNN algorithm, which is also known as key nearest neighbors algorithm. It has 3 steps on how it works, and they're summarized in the slides. Then the applications include text mining, agriculture, finance, and cargo competitions. Then under this algorithm, we talk about the parametric models and non-parametric models. For the parametric models, we know which model exactly you will fit to the data. Well, for non-parametric, the data tells you what the regression should look like. Then we also look at the Euclidean distance and Manhattan distance. For Euclidean distance, the dimensions measure similar properties, while for Manhattan, the dimensions are dissimilar. Then next, I'm going to talk about decision trees. Decision trees are a supervised machine learning algorithm, which is used for regression and classification tasks. So for decision trees, we divide bulky data into smaller, manageable sub-data sets in order to improve the accuracy of the models that we are working with. So for decision trees, we use a hierarchical tree-like structure to divide the bulky data into smaller, manageable data chunks. So it has advantages and disadvantages. The advantages include there are no assumptions about data distribution. It can be used for feature engineering, but on the other side, for the disadvantages, it's sensitive to noisy data, and the small variation in data can result in different decision trees. So it requires us to be very careful because any small change can result into different decision trees. Then I'm going to talk about random forests. Random forests are also a supervised machine learning algorithm which creates ensemble of multiple trees using the ensemble techniques. Some of the ensemble techniques include bagging, which can also be called bootstrap aggregating, and boosting. For bagging, we reduce variance by training the models in a parallel manner, while for boosting, we train the models in a sequential manner. By this, I mean, if we are training a model, we base on the mistakes made by the previous model to make sure the next model, it doesn't make the same mistakes. So we are making an improvement of the previous model. So the aim of using these ensemble techniques is to improve accuracy and prevent overfitting. Next, I'm going to go to the model evaluation metrics. These could be some of the factors that we use to evaluate how the models that we have are performing. So the factors include accuracy, train test split, precision and recall, and cross-validation. For accuracy, we are looking at the percentage of correct predictions. Then precision and recall. For precision, it's the accuracy of positive predictions, while recall is the coverage of actual positives. Then for train test split, we are looking at what amount of data is being used for testing and which amount of data is being used for training. From the research I made, we are supposed to use more of the data for training in order to get correct results, because the model is supposed to feed with as much data as possible, data that's just enough for it to perform the task. Then for testing, it's supposed to be the 20% of the data that has been collected. Then finally, the final metric could be cross-validation. Then I'm going to talk about feature engineering. Feature engineering refers to transforming raw data using domain knowledge and data analysis into input variables, which could be the features that are used to build models to identify patterns and also improve the improve the performance and accuracy of the models that we are working with or the models that we are building. Then I'm going to talk about principal component analysis, which is also an algorithm and can also be called PCA. PCA focuses on dimensionality reduction. We are trying to simplify the data sets that have many features. This could be bulky data, but we aim at making sure that we do not lose the important information while simplifying the data sets. Some of the applications of PCA are image compression, regression or clustering tasks, data visualization, and facial recognition. Then some of the real-world implementation challenges that we could face while working with machine learning could be missing data, and this can be dealt with when we are performing exploratory data analysis. Then feature scaling, temporal shifts, data leakage. This is not this is not all the challenges that you could face while implementing machine learning, but these are some of the challenges. So temporal shifts could be in a way of we used old data to train the model that we are working with, but then patterns keep changing, so we cannot continue using that old data. So the data has to keep being updated in order to fit the patterns under which we are working. Then there could be feature scaling and data leakage, as explained in the slides. So finally, I'm going to explain a problem that I thought of, which can be solved using machine learning. Which could be explained using the knowledge I have on machine learning. So a problem, I thought of an election candidate feedback system. We are previously from an election, and from my observation, candidates continue investing energy and money in voters, but they do not get feedback on what the voters think, on whether these people vote. So that is the problem I'm looking at. So the problem is the candidates do not get feedback from their voters, from their potential voters. Who is being affected? These are the candidates. So the candidates, I would think that the candidates would need to get insights into factors influencing voter support, and they would also need to get clear feedback on areas requiring improvement. And finally, prediction of their likelihood of winning, because I believe that if someone knew that chances of winning are low, they would either choose to back out of the race or invest more energy. So for the solution I'm looking at, we would use concepts like data preparation, like getting data from surveys, the past election results, social engagement, and using this data to provide strategies for the candidates on how they can perform better or engage better with their voters. Then cleaning the data by handling missing values, removing duplicates and standardizing formats, which is exploratory data analysis. Then prediction and feedback, where the model predicts the likelihood of each candidate winning. Then feature importance highlights strengths and weaknesses of a candidate, knowing where your strength is or your weakness, what can be done better, and also strategies on how you can perform better as a candidate. That brings us to the end of my video. Thank you for listening.